So we left off at acyl halides. Acyl halides included acyl chlorides, acyl bromides, acyl fluorides, acyl iodides. And we talked about how to common name it and Iupac name them. So we do oils and then the halide, or the YL and then the halide for the common name. So in this video, I told you we're going to move on to the next. And we're not going to waste any time here, folks. There's too much to cover, too much to see. Go home, go home. That's what I always say, but not here because there's still tons of stuff to talk about. All right, so in this video, we're going to talk about how to name the Anhydride family. Whew. Okay, so Anhydride. What is an anhydride? Anhydride. Well, hydride is in reference to water. That's what that's for. And you've talked about things like hydrates in general chemistry. So hydrate and hydrides are kind of the same thing here, but an means removal of. Look at that scratch. All right, so removal of water. That is what anhydride represents. So why? Why are we doing this? Okay, well, let me kind of show you why anhydride is an anhydride. Here we go. Let's say that we have a carboxylic acid, C double bond OOH with a random alkyl group over to the left. And let's say that carboxylic acid comes in contact with another carboxylic acid. Well, that also has an alkyl group on that side. Well, one anhydride walks into the bar, and the other anhydride walks into the bar, and they see each other, and they madly make sweet babies. Well, their babies in this case will be the OH on one side and the H on the other. And pop, out comes a water baby, H2O. That's their product. That's their offspring. They make water, and water is removed from these two organics. Hence, anhydride. Removal of water. Because literally, in order to make an anhydride, we remove a water molecule from the two components. And what happens now is that the carbonyl from the first person that walked into the bar is now, that lost the OH group, there's nothing there. But now it's connected because it made sweet love babies to the other anhydride, which carries the oxygen of that OH. That's how I need you to think about this. And then that is still connected to that second carboxylic acid that was present. These two R groups could be the same. The two R groups could be different. It does not matter. But the anhydride functional group is right here. That is my C double bond O, C double bond O. Two carbonyls joined together in holy matrimony with an oxygen in the center. That is the ring for the ring finger to connect them both together. Till death do them part. There is your anhydride. And it doesn't take long to rip them apart, by the way, and we'll learn that in the reaction part of the lecture schemes. Okay, so now we know what an anhydride is. We can take two carboxylic acids, react them together, remove water from the two, and create a hookup that they will eventually go home and get married. And that marriage is called an anhydride in this world. So, anhydride, removal of water, OH on one, H on the other. There's your water molecule. And again, that's how I need you to think of this. Now, we have to learn how to name them. But folks, what I'm getting ready to tell you is not going to be surprising. You already know how to name these. The difference is that maybe you just don't know what to put at the end, because that's the only thing that's going to change. So what's going to happen here, there's two different types of anhydrides. One that we call symmetrical, and the other one that we call mixed. And as you can imagine, symmetrical will have the same R group on each one of those carbonyls, and a mixed anhydride will have different R groups on those carbonyl structures. We name them kind of the same way. One is going to be repetitive, though, and we don't want to sound silly, and we don't want to waste time, and we do not write down the repetitiveness. That's the only difference between symmetrical and mixed when it concerns nomenclature. So how do we name the symmetrical and mixed anhydrides? Well, we have a modified ending. And what we do, because they're carboxylic acid based, they're going to end in oik. Oik. But not an acid, because they're not weak acids, they're weak anhydrides. That's what they are. Anhydrides. Okay, so I need to use the word anhydride in the name. That kind of makes sense. So Iupac is going to tell you the same rule. However, we're going to have to double duty, meaning we find the R group on the left and the R group on the right. We name each one of those, and we add the word anhydride at the very end of the name. So, without going any deeper into this, it's easier just to do an example. Let's draw the structure for the following. Ethanoic anhydride. Pretty simple. Here's how you do it. Anhydride. C double bond O, O, C double bond O. There you go. All right. Well, it says ethanoic. Okay, ethan means how many carbon? 2. So there's my first one. There's my second. Okay, well, what's over here? I just told you that symmetrical alkanes, we are not repetitive. So if you only see one like this, ethanoic, it means ethanoic on both sides, because I'm not going to write down ethanoic anhydride. That's silly. That's wasting my time. Why would I do that? So we simplify it down. So ethanoic is on one side and ethanoic is on the other. Ethanoic anhydride. There you go. That's all there is to it. Okay, well, let's take another example. Let's look at ethanoic methanoic anhydride. All right, no more complicated. C double bond O, O, C double bond O. There's the anhydride piece. Well, with the anhydride piece, what do I have onto these carbons? Well, one of them is ethane, which is a 2-carbon chain. The other one is a methane, which is a 1-carbon chain. Oh, well, that's all there is on that carbon, is just that one. So if I wanted to be proper, I would go through and I would put my hydrogens on. All right, so this carbon, 2 from the oxygen on the top, 1 to the left, 1 to the right. It gets none, right? Nothing. And then here at the end, well, that needs 3 more hydrogens to make 4 bonds. Now, this one here to the right, that is a carbon double bond O, and there's a bond, which is 3, and this one simply just gets a hydrogen. That's all that it gets. All right, so folks, there you go. There's ethanoic, methanoic anhydride. Okay, so now you look at the structure, and now you see the difference. The other part of Iupac that's not went away is alphabetization, right? Alphabetizing. Alphabetation. What is alphabetation? I just made that word up. So we're going to put these in alphabetical order. E comes before M, so therefore it's written first. So the question that I always get is, well, what if I put the ethane part to the right and the methane part to the left? Is that a different structure? And the answer is no. No, it's not. It's the same thing. You should know that from Chem 251. So if you do switch these up, it's perfectly okay. It's the same structure. You're going to get a correct answer. As long as one is ethane and one is methane, folks, you've got it. All right, so let's do another example. Let's say that we have a C double bond O, O, C double bond O, and on this side and this side, we've got some carbons. Let's give it a name. Let's go backward. Let's go the other way now. Okay. Well, I see this C double bond O, O, C double bond O. Okay, so there's the anhydride piece. So this side is a 2-carbon chain, and this is a ethan. Remember, drop the E and add oic, because these are carboxylic acid based. And then over on the right-hand side, this is a 3-carbon chain, so this is a propane. Drop the E and add oic acid. No, not acid here, because we don't have an acid, we have an anhydride. So there is the generation of the names that need to go in, and I need to put them in alphabetical order. So ethanoic and propanoic anhydride. That's all there is to it. Okay. Now let's take a look at another structure, and let's do C double bond O, O, C double bond O, and then we'll do 3 there and 3 here. Name it. Okay, I got this. C double bond O, O, C double bond O. This is an anhydride. Good. Over on this side, we have 4 carbons in total. Those 4 carbons in total, that is a butane. Drop the E and add oic. On this side, look what we got. 4 carbons, all over again. So 4-carbon chain, butane, drop the E, add oic. Well, I don't want to say butanoic anhydride. That's silly sounding. We don't want to sound silly, we want to sound smart. So we leave off one of the repetitive words. And here we just call this butanoic anhydride. That's it. No more than that. So what if I had a common name these? I mean, we talked about common names, didn't we? Yeah, we did. What if I had a common name them? Oh, there's no difference. You learned a common name the first time. You used it for carboxylic acids. You used it for acyl halides. You're going to use it here for the anhydrides. There's no difference. So instead of butanoic, well, the common term for a 4-carbon chain is butyric, right? So butyric anhydride. You use the same as you did for the carboxylic acids. There's no difference. So it goes back, because they're carboxylic acid based, it goes back to this whole idea of, well, formic, acetic, propionic, butyric, valeric, and caproic. It's the same process. It's the same thing. The only difference is that you might have to name more than one. Hence, let's erase this, and let's erase one of these carbons. So there we go, 3 in total on that side. And let's make the modification over here. So we'll do 2 on this side. Okay, so now let's go through and Iupac that structure, and then we're also going to go through and common name the structure. I'll show you both of them in one swoop. So we know that these are anhydrides, and that's how the names are going to end up. Those are anhydrides. There they are. This is a 3-carbon chain here, so this is propane. Drop the E, add oic. If I wanted to Iupac it, this is a 2-carbon chain, so therefore this is an ethane. Drop the E, add oic. Common names. Common names we can do at the same time. Common names over here for a 3-carbon chain is propion. And then I add the modified ending, ic. So propionic for a common name. And then over here I do the same thing. The common name for two carbons is acete, and then I add ic onto the end because these are carboxylic acid based. So now I'll just put it together. If I wanted the Iupac nomenclature, alphabetical order, so this is ethanoic, propionic, anhydride. And the common names would be acetic, because A comes first, and then propionic anhydride. And I made a mistake up here. This is not propionic for Iupac. This is propanoic for the Iupac. So ethanoic, propanoic anhydride, and then the common name is acetic propionic anhydride. Okay? All right. That's it, folks. That's all there is to it. There is your lesson, your quick cheat note for what an anhydride is and how to common and how to Iupac these structures. So I'm going to leave you with one example to do on your own. We'll pick this up in the next video. And what if I asked you to name or draw, what if I asked you to draw benzoic anhydride? Could you do it? Well, give it a shot. See what you come up with. Don't Google anything. We've not really talked about ring structures. Well, we name those kind of the same way that we've always done. But what if this term gives us benzoic anhydride? Could we go through and name it this proper way? Okay, so write down a shot, a guess, your theory. What is it going to look like? And the next video, we'll pick up from here. We'll draw benzoic anhydride together. I'll explain to you why that structure looks the way that it does. And then we'll move on to our next carbonyl group. And our next carbonyl group will be esters.